Hi guys, welcome back. Uh, in this session, we're continuing the previous lecture where I discussed the transuser questions. We learned some of the concepts of transusers, basically potentiometer transuser. Okay, potentiometer transuser, we have seen some questions based on that. Now, we're going to see some more questions, and also we have seen LDR. What is LDR full form? Just give it in the comment. What is the LDR full form? Already we have seen that because that's also one of the public questions. It is? Yes, I think you should give it in the comment. I would love to see that. Now, we're going to see another most important and mostly asked transducer in resistance transducers, which is, guess what? It is a strain gauge. Yes. So in this lecture, we're going to see some questions based on this strain gauge. Okay. So without further ado, let's get started with the first question. Here you go. Easy questions. I think you'll be able to answer it quickly. Go ahead. Timer. Let me run the timer. Why no responses? What happened to your responses? Are you not clear with the question, or I mean, you don't know the answer? Such simple questions also you're not answering. Means your preparation is not up to the mark. Twenty more seconds. I think for the sake of time, I'm taking over this. Only Vanaja has I think answered it. Okay. So let's see whether it is right or wrong. See guys, this is an easy question. It is said strain gauge, strain gas, strain gauge, whatever. First of all, it is not an active transducer. It's not an active device. It is a passive device. Active device means the one which generates the voltage. So it's not going to generate anything, right? It will not generate anything. So it is not an active transducer. It is a passive transducer. So if I had to strike two options, A and D are gone, ruled out. It's passive, and its job is to convert electrical displacement into change in resistance, converts mechanical displacement. It's not about electrical displacement, it is a mechanical force. Suppose it is stretching, there is a stretch on this, then yes, its resistance will change. Basically, this works in the principle of, what is the principle under which this works? Piezo resistance effect. We have already seen in the previous lecture about the piezoelectric effect. What is this piezo? That is also I discussed. Okay, piezo means, what is that? Piezo is a word which has derived from the Greek word which means squeeze or press. Means basically you're applying some strain and you're measuring the strain, you're measuring that mechanical strain in terms of resistance. Okay, so answer is C's answer. Okay, I hope you got it. Clear or not? I want to see some responses. Is this clear what I'm saying? What happened to you all? It's all like you're all dead and no responses. Okay, we got one, somebody saying. Next question. Try this out. Well, we already got the answers. Great. I think this is also easy one. It's about the active transducer. Definitely strain gauge is not active just now I said. I think you know Celsin, right? This is a device, self-synchronous machine. This is used in control systems. Okay, Celsin in short. And photovoltaic cell. What is this photovoltaic cell? PV cell or solar cell. This will obviously it will convert light energy into electrical energy. It is also a transducer. Rather, it is an electrical transducer. It is an active electrical transducer. It is an active device because it is inducing EMF. Okay, so this is what PV cell or solar cell. It is an active transducer. Absolutely right. Absolutely right. Okay, I'll move on to the next question. Good guys. Yep. Try this. Nice. We got an answer. Okay. Let me deal with this. What is the working principle of strain gauge? Okay, what is the working principle of strain gauge? Piezoelectric effect. No, electric effect means it gives the electrical energy. Is it giving electrical energy? Is it giving electrical energy? No, it's not giving electrical energy. What is giving then? It is giving resistance, change in resistance. So strain gauge, piezo resistance effect. Is option is matching. There is no piezo resistance, so you cannot pick anything based on the change in electrical resistance due to mechanical strain. Based on the change in capacitance, no, not a capacitance, not inductance. Yes, it is the resistance. So yes, good guys. Most of you did good job. Okay. Anyways, let's go to the next question. Sir, he's crazy, Sampath. Yeah. Next question, guys. So, okay, for the sake of time, in which type of strain gauge is grid pattern made from a thin flat piece of metal foil? It is definitely foil type. The strain gauge is the grid pattern made from thin flat piece of metal foil. Metal foil means what? Metal sheath. On the metal sheath, by etching you are forming a grid. Etching means I think you have seen you must have used PCBs when you give the PCBs for printing, then they will give that. Etching means just removing that some part of it. Okay, so it is making a grid. So basically, it is a foil type. It is a foil type strain gauge. It is a foil type strain gauge. So now this foil type can be a part of, you can say this foil type is not necessarily bonded or unbonded. So just to answer it, It is a foil strain gauge. Okay. Foil strain gauges are usually will be a part of unbounded as well as bonded also. Okay, but most of the cases it comes under bonded. But yeah, just to answer this question, C will be the proper answer. Okay, C will be the proper answer. Good. Guys, you answered for this. Okay, I'm moving to the next question. Yeah. 10 more seconds. Okay, your time's up. What is a gaze factor or a Gauss factor? Anything you know? Gaze factor is GF. GF means not girlfriend. It's a gaze factor of a strain gaze. They will normally give GF simply sometimes. So it's the ratio of change in resistance. Basically, it is the ratio of change in resistance to mechanical strain. Yes, this is right. So delta R by R by epsilon, which is a strain. This epsilon gives strain, mechanical strain. There is another formula. Can somebody tell me the other formula for this? For the same GF? There are two more formulas rather. What are the other formulas? See, that's what you have to do. During a practice session, you have to recall all the related formulas, every other stuff. Okay, otherwise, there is no point of this practice session, not just getting an answer and going forward. You have to train your brain so that whenever you see this gaze factor, all those formulas should be listed in your head. Okay. Yep. Other formulas. Try. So delta R by R divided by, instead of this, you can go for delta L by L. This is not T, this is L. Okay. There is one more formula, that is 1 plus 2 times of V, where V is a Poisson's ratio. Because this stress and strain, these are mechanical terms obviously. This Poisson's ratio, Young's modulus. Stress is equal to Young's modulus into strain, Hooke's law. That's what Hooke's law, which will be the basic mechanical behavior of anything. Okay. So I think you're familiar with all these terms, at least now you're aware of it. What is this gaze factor, stress, strain, all these. So to answer this is answer. Sometimes they may tweak this to get into any one of these forms. You should be able to identify. Okay, be careful. Huh? Next question. See, look at this question. These are all, previous year questions in some or the other exams. This is a question in TSGENCO in 2015. Okay, Telangana State Distribution Company, Southern Power Distribution in 2015. This question is asked directly. Just know I gave the formula, man. Come on. Just know I gave the formula. You have to do the math. Formula is already given in the previous question. Answer is it's crazy, huh? You don't know the basic math or what? 1 plus 2V, it is said Poisson's ratio of a resistance with a strain gauge is 1.8. Strain gauge Poisson's ratio V is given as 1.8. Then neglecting the piezoresistive effect, the gauge factor is 1 plus 2V. So 1.8 into 2 is 3.6. So 4.6 is the answer, not 3.6. 1 plus 2V, right? I think you're clear. Respond, guys. What happened to you all? Are you in a chill mode or something? Huh? I see less responses this time. I don't know what happened to you all. Anyways, next question. I think due to the poor responses, I'll be winding up the session after maybe 10 questions. We're at the 7th question now. Or with the next question itself, we'll wind up the session. Okay. Because no response means I'm not getting energy, so I'll wind up it, as simple as that. What does this high gain factor indicates about the strain gauge? So high value of gain factor means this, not gain factor, gauge factor. High value of gauge factor is nothing but, in case of a strain gauge, it is nothing but a sensitivity. What is that? Sensitivity, gauge factor, they're proportional. Okay. So high gauge factor means high sensitivity. Out of the listed or whatever the strain gauge what we have, out of all these, semiconductor type is having high sensitivity. Okay, semiconductor type gauge strain gauges will be having high sensitivity, means they'll have high gauge factor. High sensitivity is good or bad? Obviously good. Highly sensitive to the strain means input. Yeah, that's what we want. That's what rather any instrument or any measuring device want. We look for that. Okay. So okay then. I think I'm just winding up this session over here because of the poor response and all. So what's the point of continuing? Let me just wind up the session over here. If you want to continue to answer, I'll just go through the questions. I'll give the question. You try to give the answers in the comment if you wished. Okay. I know you won't be giving it. You won't be thinking too much, but yeah. Next question is this. Next question is this. Advantage of using semiconductor strain gauge. Just now I said. Backing material for strain gauge and commonly used for high temperatures, and why it is commonly used. The disadvantage of using bonded strain gauge, and this is an important one. Wheatstone bridge configuration. I mean, what for this? In which configuration? In which case we'll use this Wheatstone bridge configuration? And dummy strain gauge we'll be using in Wheatstone bridge. Quarter bridge. What is this quarter bridge? What is this half bridge? What is this full bridge? Then why do we use this dummy strain gauge in quarter bridge? What for? That's also a question. We have a few more questions, but yeah, at least these are the questions you try to answer in the comment. Okay. Okay, guys, that's end of this session. Thank you for your nice participation. Have a good time. Bye-bye. See you in the next lecture.